Hello folks, so with the 1.0 release of Envoy Gateway having just been released, I wanted to give you a quick tour of some of the features that are available now. I have this scripted up, I'll admit, so that you don't have to sit here and watch me make a bunch of typos. So let's just run through what we've got. The first thing I'm going to do is install Envoy Gateway. So this is a fairly simple Helm command. You can see we're installing version 1.0 and we're using the values file that's printed above. There's not too much to see in there. This is pretty default configuration. This should hopefully be fairly quick to install. Envoy Gateway is designed to be a lightweight ingress controller and sort of API gateway light that addresses 80% of the features that most folks are going to want to use, but without its own custom API, its own custom CRDs, without heavyweight installation and maintenance processes. Okay, so we're already done. And my script is now showing us all of the pods in the cluster. I've got a few demo applications running, so maybe representative of a cluster you've got lying around that you want an ingress controller in. I've got Cert Manager, I've got Prometheus, and now we have this one pod in Envoy Gateway system. We have this one Envoy Gateway pod, so that's the control plane sitting there waiting to go. Okay. So now I'm going to take the first step in configuring Envoy Gateway. Now this is a gateway class resource. So this is all from the Kubernetes Gateway API. This is a community-driven standard effort. So the Kubernetes used to have the ingress API that was limited in a bunch of ways. So we now have the Gateway API, and this is an official, upstream Kubernetes project. This isn't some custom set of resources. And the Gateway class, as you can see, is from that API group from the Kubernetes Gateway API. So this isn't really going to do very much at all. This is just going to give a reference to the control plane that I just installed, because Envoy Gateway lets us have multiple gateways, multiple actual physical ingress proxies running in the system, and it lets each of those be associated with a different Envoy Gateway control plane instance if that's what you want with different settings. But I'm just going to sort of set up the identity one here, so we'll just apply that. Okay, so the next thing is a gateway. Let's get some Envoy proxies running at the edge. Let's get an actual ingress point for our system. So again, from the Kubernetes Gateway API. So you might recognize this if you've used the ingress resource before, which you almost certainly have, as sort of part of ingress. So the Gateway API has a few separate resources, decouples a lot of what ingress talks about. So here, this is the configuration sort of for the running proxies themselves. So this is saying, well, I want you to run some proxies and I want them to listen on port 80. So this is the sort of lower level part of that. This is like an Nginx server block, if you're familiar with that system. So we're going to apply that. So we now have our gateway, and pretty soon it will get, because I'm running on a cluster in AWS, pretty soon that'll get a public DNS address. Okay, so we can now start routing things. So this is the other half of that ingress resource that we used to use. So this is the HTTP route, and there's other route objects to describe TCP routes, gRPC routes, TLS, SNI pass-through routes. All of this stuff is no longer shoehorned into one resource like it was in ingress with annotations and extensions. This is all properly modeled first class. So I'm going to do the most common thing, route some HTTP. So I'm running HTTP bin in my cluster. So we're going to attach to that gateway, to that physical proxy I just called apps that I just deployed. This is going to listen for a particular host name. So HTTP bin, as it happens, does not like to be path hosted. It doesn't like to be running under a subpath. It uses a lot of absolute URLs and stuff. So we're going to give this thing its whole own host name. So I'm going to match all the paths, prefix of slash, and we're going to send it to the Kubernetes service HTTP bin. So we'll just go ahead and apply that. I'll do another couple just to show an example. We'll run through them very quickly. So this is a little app, a little pod that I wrote. This is happy to be path hosted. So this is on the this is not specifying a host name, right? So this will actually match every other host name in the system. Your sort of configuration might vary. but this is path routed, and we've got two paths here, and we're going to match those prefixes and replace them with /. And then one more for another example app I've got, which we'll probably be seeing most of. It's a little utility that runs that just logs every HTTP call it gets, so that we can sort of see what's going on. Right? Imagine like an echo server, but rather than echoing the request back, it just logs it to standard out, so we can view it with kubectl logs. So this is going to sit under its own path, again attached to the gateway that we deployed. Okay, so now we can see an Envoy Gateway system. We've got the control plane running as before, and we've got another pod, which is our actual physical gateway that we asked for. So those running Envoy proxies, the data plane. So now we should be able to go and hit some of these apps. So I have this domain name under my own domain pointed at my AWS ELB, which is automatically made by Envoy Gateway. And we can go and hit EG demo. Great. So this will be the 404 page, because actually nothing on that domain matches the root path, but I can go and get HTTP bin, and there we go. And we can also find the other apps that I deployed. So let's go find HTTP log app. There we go. It doesn't do very much other than, say who it is and what version it is, and that it logged our request. So next thing we can do is show TLS. This is okay. So the next thing we can do is enable TLS. This is obviously a very common requirement. If you're hosting an API or a website, you're going to want HTTPS these days. So I can use Cert Manager to issue the certificates. There's an integration with the Gateway API, like there's an integration with Ingress resources. So we'll just, Cert Manager is already running to save us some time, but I'll show you all of the configuration to show there's no tricks. So this is a cluster issuer that's just going to use Let's Encrypt. We'll apply that. I've got the staging one as well, still left over from my demos, I guess. So now we're going to reassert this gateway. So this is the same gateway as before, but it now also listens on 443 for HTTPS. It actually now only listens for this one domain name, because with TLS obviously we do need to have a domain name, and we're going to terminate TLS, and we're going to reference a given certificate, for the public key to do that. But there's an annotation that secret doesn't exist yet, but there's now an annotation on this resource which says that if you're familiar with Cert Manager, you'll recognize this. Says Cert Manager should go and use Let's Encrypt to go and make that certificate. Okay, we apply that. And now, I've skipped ahead there slightly, sorry, we should now hopefully be able to go and access the website over HTTPS. The certificate might take a little while in the background to be minted. Let me just magically chop this video and come back when it's been done. I didn't even need to. There we go. No editing tricks there. There's HTTPS, and we didn't get a certificate warning or anything, because this is a valid public certificate because we've issued it with Let's Encrypt. So there we go. HTTPS is that simple. Right. Next feature is authentication using JWTs or JOTs. So if you're hosting an API, this is very likely something you're going to want for machine-to-machine authentication from an app, a script, or a bot or whatever. So the Gateway API doesn't model everything we want to do yet. The Gateway API design is being taken very carefully. There's a committee with a huge amount of different stakeholders represented, so it doesn't incorporate. It incorporates gateways and HTTP routes and the fundamentals. For some things like JOT authentication, the final gateway API, CID spec isn't quite there yet because they want to be very careful to get it right. So Envoy proxy, the Envoy Gateway project defines its own CIDs for that, and the idea is that all of these will go upstream, subject to a great deal of scrutiny. So this is an Envoy Gateway CID for now, and this is security policy. So this again attaches to the gateway, so it's going to apply to all of the routes, and we are taking we're basically saying that all requests need to have a JOT, and this is the JWKS. This is essentially the public key store to validate it against. I'm actually, because I give this demo at a lot of conferences where the Wi-Fi is not very good, I've got a local mirror of the JWKS. So there's actually an Nginx pod in the cluster that's serving that JWKS, so we don't have to fetch it from the internet. But it's the same deal. So we'll go ahead and apply that. Okay, so now let's try to call that. So I'm going to go and hit the HTTP log path of the Envoy Gateway. So this is exactly what we've been seeing in the browser, but because we're showing machine to machine auth, we're showing JOTs. This is something better shown on the command line. Now this one, of course, does not provide a JWT. So sure enough, so printcert is a little utility again that I wrote that just shows you HTTP transaction information. It's like a more verbose curl maybe. So this is saying we got an HTTP2 response, but it was a 401 unauthorized, and the body of that response is Envoy Gateway telling us that the JOT is missing. So exactly as we might expect. Now let's go and make a call that has a JWT. I'm just going to grab one off the internet. So this is the wrong JWT. This is not signed by my public key infrastructure. So although one is present, again we are 401 unauthorized because JWT verification has failed. And now finally we can go and call this with the correct JWT. And one that I've made is on my local system. And there we go, 200 OK. And we got the same body that we saw in the browser. So it's the same piece of software.